This is John Black, Secret Chemist. We're here to talk about how to make a carbonate. It's pretty easy. You just take the hydroxide and bubble CO2 through it while it's in aqueous solution. Meaning that if you want potassium carbonate, then you get potassium hydroxide and you bubble CO2 through it while it's in water. If you want calcium carbonate, then you get calcium hydroxide, put it in some water, and bubble carbon dioxide through it. CO2 and H2O make carbonic acid, right? And if you have a hydroxide's a base and carbonic acid's an acid and a base make salt water. So look at these examples. I got potassium hydroxide here. If I bubble CO2 through, put it in water and bubble CO2 through the water, I'd make carbonic acid, and then would react to make salt water. It would be potassium carbonate. If I had calcium hydroxide, I put it in water, I bubble CO2 through it to make my carbonic acid. It reacts, makes salt water, calcium carbonate, and water. Now what I do, because I actually buy potassium hydroxide that's already in water, so I want to, when I buy it, I put it in a tray and I want to recrystallize it because it's soluble in water. But I don't like to do it fast. I just basically put it in a glass pan and throw it on my radiator, my heater in my house. I have hot water. So it takes time for that to evaporate. And during that time that it evaporates, it's so long that it's heating up and down. You got carbon dioxide going in and out of that solution, might take a week. That stuff is already, I don't even have to bubble any CO2 in. Just the CO2 from the air did the job. Now potassium and sodium hydroxide, they're soluble. All the other hydroxides are either slightly soluble or almost insoluble, if not insoluble. So let's use calcium hydroxide as an example. Okay, so let's go down to the next example with the calcium hydroxide. All hydroxides except for potassium and sodium, I can't buy at the store. You know what I mean? I have to make it. And the way I make it is to mix it with sodium hydroxide, because most hydroxides are insoluble except for potassium and sodium. So I mix them together. This precipitates out as my hydroxide, and then but there's impurities. The salt, because you're going to have sodium chloride now. So I need to get rid of the sodium chloride, right? Okay, so what I do is I put it in a bigger container, right? I just mix those two together. Here's my precip down at the bottom, my hydroxide I just made. And the rest, and I fill that container all the way up, a big container, with water. Now the sodium chloride or whatever salt is left, it'll distribute itself evenly throughout that entire water, right? I wait and my precip will fall to the bottom. Then if you look, here's the bottom, here's the top. 75% of that, if I suck that out with the siphon or, like a turkey baster or whatever, I can get it all, 75% or more of that water out. If you think about it, let's say even you have 100 grams of salt in there that you want to get rid of. One wash, and you'll be down to 25 grams. 2 washes down to 6. 4 washes down to 0.1. And that's out of the whole, if you're only making a little bit, then you'd have smaller numbers. But if you're making a lot, to have 0.1 or 0.3 or even 1 gram, that goes, it'll be an impurity, but 0.3 grams out of this, this might be 500 grams of stuff. That's nothing, man, to have 0.1 gram, because that's divided evenly among the 500 grams or 100 grams or whatever you got in there of your hydroxide. So I fill that up and I siphon it out. fill it up, siphon it out. I do that like 5 or 6 times, or how many times I want. And during that time, because it takes so long for it to settle, the carbon dioxide goes in and out of the water, and it basically just makes the H2CO3 and converts the hydroxide to the carbonate by the time I'm done, right? Now when I get done doing this 5 or 6 times, I'll let this be wet, and I will just throw it in the oven, or put it on a radiator or whatever, and dry it up. And that's basically it, how you make a carbonate. Always remember, science is great.